For the second expression, s is equal to vt squared plus 2a. Again, on the left side of the equation, it has the dimension length L. On the right side, the first expression, vt squared. So we'll end up with lt, because there's only one t at the bottom inside the v, and t squared from this part here. So only one t will be cancelled out, and there's a remaining one t. So we'll end up with the dimension length and time lt. The second part would be 2at, and in terms of their dimensions, 2 times L over t squared times t. On this part here, we can cancel 1t from the numerator and 1t from the denominator, but there are 2 t's at the denominator, so we'll end up with the dimension length L over t. And therefore, the dimension on the left side is L. First expression that we encounter on the right side is LT, and the last part on the right side of the equation has the dimension L over t. And therefore, we conclude that this is not dimensionally consistent. Let's proceed to another example. So suppose your classmate was asked to write the expression for the hypotenuse of a right triangle using the Pythagorean theorem, and he wrote h is equal to square root of a plus o. A would mean the adjacent side and the opposite side as indicated by this diagram over here. So determine whether this expression is dimensionally consistent or not. So we will extract the expression with the guide of the diagram. By the way, it is presumed that we understand that these h hypotenuse is a distance, adjacent side is also a distance, o is also a distance or length of the three sides of the triangle. So h would have the dimension L, length. A would have the dimension length L also. And O would have the dimension length also. But this expression over here would have the dimension, if they are both L and L, they can be added. They can be combined. And then if we apply the square root, then the dimension would become length raised to the power of 1/2. So the right side of the equation has the dimension length raised to the power of 1/2, and the left side is only L. And therefore, we conclude that this expression is not dimensionally consistent. So this is a very simple topic, and yet this can serve as a very useful tool in checking your expression. If you proceed to engineering courses, you will encounter many mathematical expressions, and it is expected that not all of the mathematical expressions that you will encounter in your lecture, you will easily memorize them, or you can easily derive them. So sometimes in deriving, probably you may not be sure about if that expression, derived expression that you wrote, is really correct. So one way, if you're not sure of what you wrote is entirely correct or not, one way of checking it is via this dimensional analysis. So thank you for watching, and wassalam. In case you have questions or comments about this topic, please feel free to send it to my Facebook page as shown on the screen.